Hey, it's Mr. Allred. More separable differential equations. So we've got dy over dt equals 3t squared plus 1, which will allow us to find a general solution, and y of 1 equals 5, which will allow us to find a particular solution. And that says, what is t when y equals 3, which is a completely separate question, but using the same information. So first of all, if it's a separable differential equation, we try and get our t's on one side, so we'll multiply by dt. We try and get our y's on the other side, and they're all there. So there's 1 dy, which we can integrate to y. And then on the right-hand side, there's 3t squared plus 1 dt, which we can integrate to t cubed plus t. And I've said it before, but there's a c on both sides, and since we don't know what they are, we can combine them into a single constant. Just call it a single c. So there's our general solution. So now we're going to figure out what c is using that condition, y of 1 equals 5. That means t is 1, y is 5. So we plug those in, we get that c is 3. So our particular solution is y of t equals t cubed plus t plus 3. And then the extra question they asked us up there, which may or may not be asked sometimes, but it's good to understand that you can do it. When y is 3, what's t? So we put 3 in for y. We solve for t. Here we get, after we clean everything up, we get 0 equals t times t squared plus 1, which we can separate into two equations, one being t equals 0, which is a solution. The other one, t squared plus 1 equals 0, has imaginary solutions, so we don't get anything from there. So we only get one solution when y equals 3. Okay, let's do that's all our examples. All right, thank you.